Hey guys, this is Coach Brian. This is going to be more of a quick one looking at 3.7 practice. Overall, our practices are getting shorter, so I'm not going to do the complete thing anymore because this is the part where you need to be doing some practice. Today, I'm going to focus on question number two. Question number two requires you to kind of dig back into your algebra backgrounds here, and this is kind of a concept that a lot of my students used to hate, and I hope this doesn't make it more confusing for you, but I want to talk about a couple different approaches to this one. So first of all, we have one given angle right here. That's 90 degrees. We know it's 90 degrees because of the little symbol that's used there. And because this angle is 90 degrees, it also means that this one equals 90 degrees. And because of this mark telling us that these two lines are parallel, that angle also corresponds to this one. And that tells us that it's 90 degrees. So, we know off the bat, all of our angles equal 90 degrees, okay? They all equal 90 degrees. So, what I would like to do is talk about a couple different ways you could approach it, okay? The first thing you could do is you could go ahead and start with this 2x, knowing that it equals 90. And you could very quickly divide by 2, and you get that x equals 45. And if you know that x equals 45, you could then plug that in here and solve 3y minus 2 times 45 equals 90. All right, that is, in this case, probably the easiest way you could get there. Now, for the complicated way, but the way that could probably help you more in the future for harder math problems. There's a concept from algebra that I remember many of my students hating called substitution. So if I was trying to figure out 3y and 2x, and I knew that because they are equal, I knew that these two angles equaled each other. We already said how we know they both equal the same thing. Then I could take 3y minus 2x and set it equal to 2x because I know that those two angles equal each other. And then adding my 2x over, I would get 3y equals 4x. I could then divide by 3, and I would get that y equals 4x over 3, or 4/3 x. Once I have this value, I can then plug it into this equation like this. 3y minus 2x equals 90. 3 times 4/3 x minus 2x equals 90. I would then distribute this. 12 over 3x minus 2x equals 90. And that would reduce to 4x minus 2x equals 90. Combine like terms. 2x equals 90. Divide by 2. X equals 45. And then plug that in and solve for y. Ultimately, what you should get is that 3y minus 90 equals 90. You'd add 90 to both sides. So you'd get 3y equals 180. Divide both sides by 3. And y equals 60. X equals 45. So I hope that the little substitution part didn't make it more confusing, but it may have. But regardless, that's two different ways that you could solve number 2. One is all about making conclusions based off of what's given, and question number 3 is about completing the proof. So if you look here, you're going to start with some information that's given. You have your possible reasons here. And ultimately, you're trying to prove that BC, this line right here, let me change colors, BC is perpendicular to CD. That's what you're ultimately trying to prove. So hopefully this helps. And